So, just so you can see us, I'm Diego on the left, and this is Luis on the right, the ones that are speaking. This will be briefly what we are doing today. We will start first using some existing packages of famous C and C++ libraries like Boost and Poco, and then we will see how can we create our own packages and also reuse our own packages in a small project. So let's start with the first one. Then we are having a CLion project that we depend on both Boost and Poco libraries. And we want to develop this simple application installing these libraries with Conan. So let's start with it. So I have prepared here a GitHub repository with 4 folders. These should be actually different repositories, but I've put in a single one for simplicity. But each one of the subfolders will typically live in its own repository. So first, I'm going to clone the repository. Okay, got it. Then move into it. And I'm going to start with the Boost Poco example. Okay, as we can see, we already have a CMake list.txt in the root of the folder. So having a CMake list in the root, automatically we can open it as a project in CLion. So I'm going to open it as users, CLion. Yeah, and in CLion, I will see, yeah, this is the folder. Okay, so loading it. I'm going to show you first the source code is very simple. I can see the include for the Poco library, that is a very famous C++ framework. And also I'm using here the regex library from Boost. Here you can see the code for computing an MD5 with Poco, and then I'm using a Boost regex to check a couple of emails. So this is very simple source code. I'm going to build an application with it, a very simple executable application. And for this, I have the first thing I need is I need to declare my dependencies. In the simple case, I can do it with a Conan file.txt. It has this look. We have a require section in which we will say our dependencies. And then we'll have the generators. The generators tell Conan that we are going to use CMake as our build system. Because Conan supports different build systems, you can use different generators. In this case, we are telling Conan, hey, we need a CMake file to link with our packages, with our dependencies. Why? Because if we check our CMake file, we have this. We have here our application from the source code. It is linking with some libraries, and it needs some setup. It needs to know where the headers are, so the input directories. It needs to know also the library directories, the library names, and this can be done with these 2 lines. These 2 lines are getting a Conan build info.cmake file that will be generated from Conan. When you run Conan install and you install the dependencies, Conan will generate this file for us. Actually, if we check the CLion CMake output, it just told me that I have an error here. Why? Because this file doesn't exist yet. I have not installed my dependencies, so the file is not existing. Okay, so the first thing is I'm going to install my dependencies. So for that, I have a terminal here. I'm going, okay, by the way, an important thing, the Boost and Poco libraries that we have them previous binaries for them in bintrate. We have binaries for many different configurations. But I'm working right now in Windows. And for Windows, I don't have min.gw binaries, previous binaries. And of course, I don't want to build Boost and Poco from source stuff right now because it can take the whole webinar. So what I'm going to do is I'm going to switch my settings. So I'm going to use the Visual Studio compiler from CLion. And also in CMake, I can specify the architecture. So I'm going to specify the 64 bits architecture. Okay, so I'm applying. So from now on, I'm using the Visual Studio as a compiler. So my application will be built with CL compiler. Okay, so now I'm going to install my dependencies. I'm moving to the CMake build debug folder, and I'm going to install my dependencies from there. Why? Because the dependencies I want to install the debug packages, because I'm working in debug mode right now, so I have to install the dependencies in debug mode too, so they work. So I'm issuing a Conan install command, and now I'm specifying my settings, because Conan is explicit. It won't try to detect your configuration like very smartly or whatever. You have to tell Conan that you want your dependencies for Visual Studio, and you want the dependencies for debug. In this case, I need to specify the compiler, so I'm going to use Visual Studio. Okay, I'm in debug mode, so I need to specify also the compiler runtime will be also the debug runtime from Visual. I'm going to specify my build type is going to be debug, and my compiler version is 40. Okay, so I think I have a mistake. Yeah, sorry, because of this, it's an extra space here. Let's try again. Okay, so I got some dependencies. Actually, I'm going to show you what I've just installed. Conan told me that it has installed several packages. Actually, not only Boost and OpenSSL, Boost and Poco, but also OpenSSL and ZLib. So we are going to do a quick inspect of why. So we are using the Conan info command, and we are going to specify that we want to output an HTML file. Let's open the file. And here we can see it. We are depending on Boost and Poco. Okay, but in turn, Poco depends on OpenSSL, and OpenSSL and Boost too, they depend on ZLib. So this is why OpenSSL and ZLib have been retrieved, because they are transitive dependencies of both Boost and Poco libraries. So now that my dependencies are installed, I can go to CMake and I can say reload. And now CMake will not complain. My CMake build debug configuration will be enabled, it was previously disabled. And you can see right now that CLion is building symbols. So it is right now constructing all the meta information so we can navigate, and we can have the autocomplete. We can also have the helpers and outline the errors that we are making. It takes a while, but it makes sense because right now it is indexing the full Boost libraries, the full Poco libraries, and also OpenSSL and ZLib, because we added them to the path. So it only took several seconds, and it indexed like the two largest projects out there. So it's not bad. From now, we have all the features because it is actually understanding what is happening, because it has the information for our dependencies too. Okay, so the CMake configuration now runs okay, and everything is fine. I can just build and launch my application, and we can see here the output of the application running. Okay. So with this, we have used some packages that, okay, I must recognize I've cheated a little bit, because those packages, they were installing on my machine. I didn't want to depend on the network right now, and actually like retrieving both Boost and Poco. Boost is several gigabytes, so it will take a while to download and unzip. But otherwise, I'm just using normally installed packages from the tray. Okay, so this is how we can consume existing packages. If we would like to also to build like the release configuration, we will just repeat the steps. So we will enable the release configuration here, and we will install the dependencies for the release configuration, and we will just build the demo application exactly the same. So the most interesting part here is how to create packages from my own source code. Okay, so what I'm going to run now is this small example application. So I'm going to build this. The hello will be a library that just outputs in the standard output like a hello world message. It will be a package. Then I will have another package that is going to be called the chat package, that is also a library that depends on the hello library and also adds some functionality. And itself is also a package. And finally, I will have another project. It will be called the social network project that depends on the chat package and transitively on the hello package. Okay, so let's start with the hello one. So you have the source code in the repository. I'm just going to open it. So let's open the hello project. Okay, the first thing we can find is a CMake list in the root folder. It's a very simple one because it is just adding as a subdirectory the source folder. Okay, and if we check into the source folder, we will see like the main CMake list that is creating first a library with the hello CPP source file. Then it's creating an application. It's called grid application, and this application will depend. It will link with the hello library. So this is very simple CMake stuff, and I can show you the code. It's also very simple. So we have the grid application. It's just calling a hello function, and this hello function can be found in the header, and you can see also the implementation of the hello function. It's just an output message to the standard cout. So this is my application. Everything is standard CMake, anything related to Conan yet. So yeah, I'm going to switch to MinGW because for this example is good enough and it's fast. So I'm going to use, from now on, I'm going to use MinGW. Okay, and now this is a standard CMake and a standard C++ project. So CMake is still running, and I can just load in symbols. Okay, so I can just build and launch my application, and you can see here the output message. Okay, so this is good. Now the question is, how can we take this library and make a Conan package from it? So the first thing we need is a Conan file. This Conan file is this Python script here. I won't explain it in detail. You can find more information in the Conan documentation. And also there are other webinars that treat specifically about this Conan file. So I just want you to check here this is the recipe, the part of the recipe that is building the package from sources just using CMake. This is just a very thin wrapper around CMake calls. Then we have the package method that is extracting the artifacts, let's say the headers and the libraries, from the build folder and putting them in a specific package folder. All the packages are stored and they are built and there are processes and they're installed, everything in a local folder that is called the Conan local cache. That local cache is a folder inside your user home. And so all the packages that are installed there. So if you have different projects, all of them, they will find the packages in that common location. It's a way to share libraries like push. You don't want to have many copies of Boost in your computer, so you will have just one package of Boost in your local cache. So this operation here, this build here, and this package here, they are not working in the current project. They are working in a different folder that is the Conan folder. Okay, so with this package recipe right here, we can build a package. We can fire within a package. So what I need to issue is the test package command, and I also want to specify my my configuration. I want to say, okay, I'm creating this package, and I'm creating this package with a binary for this specific configuration. So I could do something like I did in the previous example. So I could say, hey, my compiler is GCC, whatever. But I'm not doing that. Instead of that, I'm going to show you my profile for GCC 4.9. Okay, so our profile is just a text file. It's a text file you can share with your team, and it is just like the set of settings you will be using in the command line, but instead of typing all of them, you can just put them in the file. That is more convenient. So here we are creating a package for Windows, GCC 4.9, using the libstdc++ version in debug mode, and also for 64-bit architecture. So with this, I can say, okay, I want to create a package with this configuration. And now it is building the package. It is doing a fresh build, a completely clean build, okay, to ensure that everything is reproducible, and it will be exactly the same in any machine I run this process. And finally, it is running a test to check that the package is working fine. So if we search in our local cache with the search command, I will see that I have several libraries. I have Boost and Poco that I used in the previous example, but now I can see that I also have the Hello library. Okay, and if I search for this specific library, I will see all the binaries that I have for it. In this case, I only have one binary. I just created it. So I can see that I have a binary for 64-bit architecture, debug, GCC, and so on. So I could repeat the process. So I can say, okay, I want to create and test another package. I'm going to use the GCC 4.9 configuration. But in this case, I also want, for example, instead of debug, I'm going to build for release. Okay, so now it is building the package, and now it is building a small example to use the package and to check that everything is okay. And this is the output of my package when it is used. So everything looks good. If I search again for my package, I will see that now I have two binaries. I will have one binary for the debug mode, and I will have a different binary for release, because they are actually different binaries. Okay, so far so good. So now we have this project here. So we can change the source code, for example, like hello. I'm going to change the message, and then I can build again, and I will get a different message. Okay, I can keep developing, doing changes, build, debug, try, run test, whatever. Okay, everything is good. And when I'm done, okay, so I want to create the package just exactly as I did to really have the package. Okay, so now we have the Hello project working, and we also have the Hello package in our Conan local cache. So let's go for the next block of the application. Now I'm going to develop the chat part of my application. So I will open it. In a new CLion project. Okay, we have a root CMake list that is exactly the same. It's just a project with a subdirectory that is using the source folder. And then I will have here another library, okay, that is the chat library. The chat library is outputting its own message with this message, and then it is calling hello. So then it is requiring the hello header. And of course, this, in order to build this, I need to depend on the hello package. So for this, the process will be the same. I will have in my CMake list, I will have the Conan build info, CMake, and these two lines, so my chat application can be built exactly the same as we did in the first example for Boost and Poco. Okay, so the difference here is that I don't have a Conan file.txt. What I'm going to have is a Conan file.py. So I'm going to have a recipe. Why? Because I want this not to be only an end consumer, but I also want to create a package from this chat library. So what I'm doing here is, okay, I'm providing my package recipe. If you check it, it is exactly the same recipe we used in the previous example, but it has like a main difference, is this line here. Okay, this line here will be exactly the same as the required section we used in the Conan file.txt version. So I'm saying here, okay, so this package depends on the hello package. Okay, so with this recipe, also it happened the same as it happened with Boost Poco. The first time I just opened the project, I didn't install my dependencies, so CMake is not able to find Conan buildinfo.cmake. So the first thing I need to do is I'm moving to the CMake build folder, and then I'm going to install my dependencies. And I'm saying, okay, I want to install my dependencies for this configuration using GCC 4.9. It created the Conan buildinfo.cmake for me. So now I can already reload my project. I can now start working on my application. So I can build my application. I will see the output. So this is the message that the chat library is doing, the source code, and this is the message that comes from the hello call, from the hello package. So I can, right now, I can change the message here. I can rebuild, and my message will be changing. Okay, so everything looks good now. So we can create a package from this chat library. The process will be the same. I will go to my terminal and I will say Conan, create and test this package for this configuration using GCC 4.9. So again, it is doing a clean build in the local cache. So the build that we just saw when running Conan test package is a clean build in a different folder. This is not the build that CLion is running in the IDE. This is something that we will do later. So if we check now our local cache with Conan search, we will see that we have both the chat and the hello package. Both of them are there. Okay, so let's suppose that those packages, they are good enough. They are good, and we want to share them with our team. So what I could do is I want to at least to show you that I can upload these packages. Okay, I'm going to upload to my Artifactory remote server, and I'm going to upload all the binaries. Are you sure? Yes, I am. So right now it is uploading the hello package recipe and also all the binaries that I have created for hello locally. Everything looks good here. Sorry, let me check. Something might be failing with my internet connection. Yeah, it won't kill the process. Okay, hold on. I'm going to close CLion, and I'm going to open the project again. Okay, I will check that everything is right, so I can build my application. And I'm going to Conan upload hello. Yes. Okay, don't worry, because we don't really need this. I don't know what is happening. I think it might be my internet connection after I connected for the webinar. So let me just close this, and I will skip this part of the webinar. Okay, so the important thing here is that right now we have two packages. We have the hello package and we have the chat package. We can also search for the binaries. I have for chat. In this case, I only have the debug version, so I have one binary for the chat. I can also see that is dependent on the hello package. So let's move on and I don't know what is this. Yeah. And this is the chat that is working fine. Okay, so now I have the two packages working fine. I'm going for the third one. So I'm going to open it. It is called social. And social in this case is just a simple application. Here we can see that is calling twice the chat function. So this is why it is depending on the chat package. It has just a text file because I'm not creating a package for this final application. I'm just consuming the existing chat package. So here I can see my declaration of my dependency, and I have my my CMake stub using the install libraries. So the first step here would be to install my dependencies. Oh, sorry. This is Conan install. Yeah, that should be it. And now I can reload CMake. And I should be able to build and launch my social application that, if you remember the source code, it was just calling twice the chat function. So this will be the first call to the chat function that is in turn calling hello from the hello package. And this is the second call to the chat function that will be also calling again hello from the hello package. Okay, so now we have our project set up. And you could say that we have a problem. Let's say that we move back to the chat application, and now I'm in the chat project. And okay, so this is no longer a small project. And every time I do a small change like this one, I build locally. But here I will be doing an incremental build, okay, and it will be fast enough. But when I move to the terminal, and then I start doing like Conan test package, I told you it is doing a clean build. So it's going to be a build from scratch. And let's say that our chat library now is huge and it takes half an hour to build. So of course, what we don't want every time we do a change in our source code, I don't want to completely regenerate my package from scratch. Okay, so let's see what could be done. The good news is that we are in a very friendly environment because we are using Conan, this Python script, and we are using CMake, that is also scripting. So we can do amazing things here. So I will show you the first step. Let me close this. Okay, so you know that CMake has a cool feature. It's called the install feature. If you are using CMake, you probably know about it. So let's say, okay, so I could make my CMake list from the chat library. I could do this. So I could define an install for my targets, for the chat target, and I can say that the libraries and the archives will be output, they will be installed to a lib folder. And I can also say that the chat.h, the header for this library, will be installed in an include folder. And I can also add a custom command that every time I build chat, it will do the CMake install. Okay, so this is nice because, okay, I have this functionality here that is implemented in CMake. Then maybe something here in my package recipe is no longer necessary. What? The package. Because you don't need to specify your artifacts anymore. This is already defined by CMake itself. So we can completely remove the package method, and we can just tell CMake this way, CMake install prefix. So this will be the install prefix when we are building the package into the local cache, will be just your package folder. Okay, actually this line here will be also automated in the next Conan release. So you won't need to type it explicitly. It will be there by default. So no need to add it from next Conan release. But right now, you can just define it. So when you are building the package, it will use the CMake feature to create the package instead of the Conan package method. So this is nice because when we are in CLion, we can go to the settings, we can go to CMake, and then here we have our configuration. So we can specify here the install prefix, and we can say, for example, something like my package. Apply. Okay. And this is the first step. So now, every time I build my application, okay, CMake will create this folder for me. So you can see here my package folder that will feature and include a library folder. This is basically the package layout, just an include folder and a library folder. So my package is already there. I don't need to rebuild that. So if I want, okay, these artifacts are local. They are in my local space. So if I want other Conan packages to use them, I can do it. So I can move to my package folder, and there is a Conan command. It's called Conan package files that will just put these binaries into this package that I'm creating. And I have to specify these are the binaries for this configuration. And the last, if there are some existing binaries, I can override them without asking. Okay, and that's it. Now, every time I change my source code, for example, I will add here 1, 2, 3. I will create my package. And now, in the Conan local cache, I don't need to wait for half an hour until the package builds again from sources and from scratch, because I can just, okay, so Conan, these are the binaries for this configuration. So finally, I can go to my project and just launch it. And as you can see here, it will be using the latest changes that I've done in the other project. So I can go back to my chat project, remove this dummy message. I will test locally. Okay, everything is good. I can say, hey, Conan, these are your binaries for this configuration. And finally, in the other project, in the social project, I can just launch again, and you will get the new message. So the good thing here is right now, we only have one build for the chat package. We are building locally with CLion, and we are just committing those binaries into the Conan local cache. Can we go one step further? And the answer is yes. Okay, I want to avoid completely this step here, that I'm doing the Conan package path. So the first thing I tried for this was create here a custom task. So here I was adding like a Python script to automate this task. So instead of typing in the terminal, I could just launch a task here. That was very convenient. But then I realized that there is a better way that I can show you. Okay, so we know that our binaries for the chat package are here in my package folder. So I'm going to show you a bit of the internals of the Conan build info.CMake. If you remember this, we are including this generated file in our CMake project. So the first thing I would like to tell is that Conan has two modes for CMake to work. This is the one you are seeing right now is like the legacy one. Is the one that is backwards compatible with CMake, I think down to 2.8. But if we are using a modern CMake, I can do this. I can enable the modern CMakes, saying that I'm going to use targets. And instead of linking with all the Conan libraries from all the dependencies, I can link with the target that I really want to link with, that is the chat target. All the other targets, they will be transitive, managed by CMake. So this, I can reload the changes, and now I can build a social application, exactly the same. But now, instead of using a global configuration, I will be using modern CMake configuration using targets. Okay, so this is the first thing. Then I would like you to have a look into what we have in the Conan build info.CMake. So I'm going to open it. So here, this is a lengthy script, but it's very simple. Because first you have like a set of variables. So you will have variables for chat. You will also have some variables for the hello package. You will have some aggregated variables. Those are combined both hello and chat flags in order. So for example, if you check here the libs, you will see that the Conan libs variable is using chat and hello in the right order. So it will link first with chat and then with hello. That is the order that GCC needs to properly link with. So you can use this to globally link with your dependencies. So you have a lot of variables, CMake variables, and then you have some scripts, some methods, or some macros. Some macros and functions of CMake. And these macros and functions, they are basically just getting these variables here that you can see all of them. They are Conan variables, and they will apply them to real CMake. So they are actually applied in your build, because these variables they do not affect the standard CMake. So you can now understand why two steps here. In the first one, we include the file, so we get all the variable definition, and calling this macro, we will just use those variables to really define the CMake build. The good thing about this is that this is the perfect place. Let me copy this to configure this. So I'm going to make my font a bit smaller to do a change, and I will do it larger. Sorry, my mistake here. I copied the wrong lines. Actually, I wanted to copy the include directories and the libraries directories. Oh. Yeah, I want to copy these two lines. So what I'm going to do right now is I'm going to define my path. So this will be it. And the same for the library directory. Okay, so this will be my final CMake list. I'm going to reload. So what we have here, okay, so you get the Conan defined variables. You define your own for the chat package, and then you define your build using those variables. So right now, this project, this social project, is linking not with the local cache, the Conan local cache, but it is directly linking with this folder here, the folder that we just defined here. So with this, I've just enabled that I can simultaneously work both in the chat project and package, and also on my social network project. So if I do a change here, I run and build locally in CLion, and I go to the other project, I launch my application, and I will see the changes immediately. And I'm not using the Conan local cache at all. So here, if you want to also simultaneously edit the hello package, just add the corresponding lines here and repeat the process with hello. Okay, so this is what we can do today with the current version and everything. There is ongoing work. So these two lines here, we will automate them in further Conan releases in the Conan project feature. So you will get this functionality automatically. So with this, I'm finishing my presentation. So I think now it's time for questions. Yeah. So this will be it.
Thank you, Diego, for presenting. Yeah, we have a couple of questions. So, and I would also like to even handle some questions maybe in voice that we've already answered in the question page, since they are quite important. So the first one I will take by my own. So, and that's the question about CLion integration with Conan and some UI integration and some similar questions. So currently there are no special UI integration or something, so you have to call all the commands from the terminal, from the built-in terminal, or any command line you prefer. However, I would like to say that we do consider some future work in this direction together with the Diego. So we considered some scope for probably some plugin that we could open source so that the whole community could contribute. So this is currently the idea under discussion, so there's nothing planned or something like that, but still we are discussing that, and probably we could come up with some integration in the future, so hopefully we'll have it. So that was about the integration in CLion, and now some questions that I hope Diego could handle. So the first one was that actually you were showing the examples on Windows, so, and the question was how actually about Linux? So is it like working the same way, or are there any specific on Linux?
Yeah, so that's a very good question. So Conan is portable in Windows, Linux, Mac, and it also works in FreeBSD and Solaris. So practically any platform that can run Python it will be able to run Conan. And as also you have also CLion, also totally portable in those systems. The process for in Linux, for example, will be exactly the same. The only thing that will be different is that in your profile, I named my profile. Sorry, let me. Are you still seeing my screen? Yeah, let me.
Yeah, we can see you. Perfect.
Okay, good. So when I show you my profile here, profile show GCC 49. This profile has Windows as a setting because I'm in Windows, and the binaries that will be created in Windows will be different than the binaries of Linux, of course. So the only thing that you should change for running Linux would be your profile. And in your profile, you will probably have OS Linux, and that would be the only change. I think all the commands that I've used and CLion configuration and CMake and everything will be exactly the same in Linux.
Okay, thank you. So the next question was, does Conan support cross-compilation?
Yes, it does support cross-compilation. Actually, we are aware of some users that are heavily cross-compiling. There are several features for this. For example, we have the build requirements that you can use to inject dev tools and tool chains, so you can use them. The CMake helper that we were seeing here in the, let me show a recipe. This CMake helper here has already some code inside that will handle like cross compilation. So you can perfectly use your own tool chains to define your own compilation. I think we have plenty of documentation in our web page. You can see also, for example, cross compiling to Raspberry Pi, cross compiling to Android, and also you can cross compile from Linux to Windows and from Windows to Linux. So yeah, cross compilation is very, very supported.
Okay, thank you. So we have time for a couple of more questions, I guess. So the next question is, which languages does Conan support? And the question was like, besides C++. So are there any? Which are they?
Yes, actually, as you can see the recipe, it is something quite generic. So you have like a build, a package. You also have like a source method you can use to git clone external sources if you want. So we realize that the Conan recipes are very flexible, and we build some proof of concept. So for example, for Golang, we have a proof of concept that you can use Conan to manage dependencies for Golang, and it works pretty well, actually. The thing is that the Golang community won't use it, so we don't even try to promote it into Golang. And there is also a nice feature, is that you can create Python packages also with Conan recipes. So this is a feature that some users were requesting because they were like repeating themselves from recipe to recipe, and they wanted to reuse Python code. So what we did, okay, so you can create Python packages, and you can depend on those packages as DevTools to inject the source code into your own recipes. So you can create like a Python package manager with Conan, and also use as to develop Python, but also to reuse that Python code into your recipes. I think this is also well documented in our documentation. Is docs.conan.io. You can see this too.
Okay, thank you. So our next question is, how can I start my own Conan server?
Well, there are a few options. The first one is the open source Conan server. It is included in the distribution. So when you install the Conan client, you already got server. This is an open source server with the MIT license, and you can launch it very easily because it's an application. If you are using it for production, you can use with a front end like Unicorn or something like that. but it is typically very easy to launch. And then if you want, like, you need something more powerful to scale to big teams and everything, now Conan has integration with Artifactory. So Artifactory has Conan repositories, so you can create your own Artifactory instance with Conan repositories, and you can use it. And finally, we have also bin tray. So if you are distributing, for example, open source, you can create packages for open source libraries and distribute them via bin tray. So these are your options. So for running your own server, it would be Conan server, like open source, or using Artifactory.
So, and I guess the last question for now, and the rest we'll handle later via email, is, so the last question is, who will support BoostLib in the repository? So it's like, because the Boost is not using CMake for the build, so that's why the question, I guess.
Okay, so the thing is that Conan is not attached to CMake as build system. So Conan can actually package any build system. As you have here, the build method, instead of calling CMake, you can call Boost build. And this is what is being done to package the Boost packages we have right now in bin tray. They are built this way. You are not using CMake to wrap Boost or whatever. You are just using the native build scripts of Boost to create the Boost package. So this works in the two directions. So you can use any build system to build the package, and you can consume those packages with any other build system. So for example, the Boost packages that are created with Boost build, you can consume them directly from Visual Studio, because if you use the Visual Studio generator, it will create a Visual Studio properties file for you. You can add to your project, and it will have all the information it needs to correctly link with Boost. So this is the way we are doing the Boost package.
Okay, yeah, so totally makes sense to me. So with this, I would like to thank you, Diego, for presenting, and thank you, Luis, for helping me with the questions. So like right now to share a piece of useful information before we wrap up. So wait a second. So yeah, so here we are with some piece of useful information. So as I said, the video recording of the webinar will be available in 2 or 3 days starting from now. So it will be on JetBrains YouTube channel, and we'll announce it via our social media and blog. So feel free to provide any feedback to JetBrains and Conan via Twitter or via comments in our blog. And if you'd like to know more about CLion, just go to jetbrains.com/CLion, or just visit the Conan.io site for information about Conan. And I would also like to say that in August, so August 17, we'll have another webinar about refactorings in C++ by Arnemertz. So the registration will be started shortly, so check our blog and Twitter for the links. So I hope that in 1 or 2 days we'll start it. So thanks everyone for joining us today. If you'd like to learn more about upcoming webinars, just subscribe to Twitter. We'll be happy to have you next time for the webinar. So thank you, and developers' pleasure.